We are starting second group elements from beryllium to barium. Let's look at their occurrence and production first. So main properties of group 2 elements. They all are metals. They are located at the left side of periodic table, just parallel to first group. They have 2 electrons on their outer shell, so both of them are s electrons, and they can be easily removed. So the only ions these elements form are 2+ ions. Size of these ions is very different. Beryllium ion is fantastically small, so small it can have only 4 other atoms around it. Magnesium is much larger, approximately the size of lithium, and calcium, strontium, and barium are all much larger. From mechanical properties, they all have higher density than alkaline metals, still very light, lighter than usual metals, but relatively high density, and beryllium is slightly higher density because of its very small size. Melting point of beryllium is relatively high, somewhere between temperatures for copper and iron. Magnesium melts much easier. All others are in vicinity of 800, 700. Occurrence. Beryllium is a relatively exotic element, and it has several minerals. Of them, most known is beryl, from which the name of the element is coming. They are very pure samples of beryl that are absolutely colorless and absolutely transparent. They were among the clearest known crystals, so the first eyeglasses, when they were constructed in 13th century, the lenses were made of beryl, because at that time humans could not make glass clear enough. Because of that, name of glass is still related to beryl, brillen in German, brill in Dutch, and briller in Danish. They are colored minerals of beryl structure with vanadium and chromium admixture, which make them of red-purple color and emerald green color. And emerald is beryl with chromium admixture. As you perhaps know, it's a precious stone. Calcium carbonate, calcite, can make very beautiful transparent crystals, and an interesting property with clean crystal, you have the image doubled. That's why Doppelspalt, doubles, but not name of this. Another famous mineral of calcium is gypsum, calcium sulfate with 2 waters, and apatite, calcium phosphate with chlorine, fluorine, hydroxide, which forms fantastically beautiful colorless crystals. the admixtures can paint them in different coloring. Metals can be obtained from their minerals by electrolysis. To run electrolysis of beryllium, you need to make beryllium chloride, and you can receive metal of very high purity. To receive beryllium chloride, usually we first make beryllium by reducing beryllium fluoride, relatively easy to make, by magnesium, obtaining beryllium metal, and then dissolving it and purifying it, and then again running electrolysis to make beryllium of very high purity. There are several uses of beryllium and beryllium alloy. One of them is that beryllium is uniquely transparent for X-ray radiation, so all X-ray windows are made of beryllium. It doesn't absorb X-ray. Relatively expensive and very toxic metal. Magnesium is produced in fantastically large quantities. It's relatively stable on air. The main problem in production of magnesium is very high reactivity when it's warm towards water, oxygen, and moist air. By saying air, I mean not only oxygen but nitrogen as well, which is relatively unusual. Otherwise, we run electrolysis of magnesium, obtaining Mg metal and chlorine as side product. Calcium, strontium, and barium are also made by electrolysis of their molten chlorides, and they need to be protected in airless environment.